Well, this is the DC rudder actuator. So you can see right now it's in a standby mode. And what that is it allows you to operate on this or work it on with it and not have somebody from the wheelhouse inadvertently hit a control when you get your hands jammed. So you can do maintenance on it in this mode, but also you can jog in and out. So for instance, you can pull it in and it will go into slow speed. I didn't engage the high speed for this because of safety concerns when you're operating it, but you can spool it all the way out or all the way in. As you can see, as it goes out, it goes into pretty slow mode, and it will go all the way out to its end stop, so you can check its travel. This would be a good time to grease and lubricate the shaft itself, and it will automatically stop. So that's what happens in the offline mode here, and you can jog it in and out. Also, if you wanted to go to the run mode, you just flick the switch up, say it's all maintained and everything's ready to go, and you want to go to the run mode, this will automatically spool back and go to a center position because the joystick's in the center position. So now that will have control when I flick this switch. You'll notice that it went to a high speed and then to a slow speed to a stop. That's because it has two different windows. One is for high speed, one's for low speed when it gets close to the center position or wherever the joystick is. This is fully proportional, so if you move the joystick, this is friction, so if you move it, say to here, it will go there and stop, or you can just make small movements with it, really small movements, and back and forth, or aggressively. Now, normally in the operation of this vessel, being that it's so large and so long, we really wouldn't be aggressively steering it. Sometimes you will, but most of the time you can just be going just small movements like this, back and forth, to maybe counteract some wind or some gust. So you're moving it back and forth, and that will be the normal steering. But you can aggressively, like I said, go one way or the other. It's aggressively, and the more you are from where it is, the faster it will travel until it goes to a slower window and comes in. Again, goes all the way to its end stop. So on here, there's end stops. We talked about the safety of end stops. We have mechanical and we have electronic end stops. So the electronics work first, then the mechanical are secondary, and then third we have dead stops that will pop a breaker here designed to do that. So when this comes to a stop, there's no way it's going to go any further than that because it's dead stop. But you'll have two electronic end stops, or two end stops prior to that. So when we think about also, this is a little bit different than the pitch actuator. This is designed with a shelf because we have a much longer unit here. And so I put the electronics on the shelf. Some are here, but most of them are out here in the actual power supplies that will provide some of the heat force. Over here we have, in this part of it, a Teflon block which will stabilize if there's any side forces coming through here. This in here, I don't know if you can see it or not, but this right here is actual track that goes in and out, a ball bearing track, which keeps everything steady and straight. When it comes out here, there's also an ice shield of this that will break ice off if it gets stuck on here during operations. And say you only go this far, but if you pull it back in, it cleans it all off. So it's a kind of maintenance free for the end of that is concerned. Here's where the clevis will go right here on this end, and I'll be sending a video of that shortly. But here is the finished rudder actuator, fully operational, and you'll see other videos of it when we get the skin and it completed.